Going live? It hasn't gone live yet? Oh, I am live now, finally? What? Did it just finally go live? That's ridiculous. Come on. All right, there. We got some music. Now I feel like I'm an official opening the whole thing. Today is a little bit different. We're going to have some chit chat. Don't you worry. But today, look at this. Ready? Oh, yeah, we got Paul Ramsey with us today. Yes. So, so today we're trying something new. I just messed up my camera. Let's see if it ever returns to me. Come on, camera. I really do need a new camera. Or I wonder if it's overheating because it's in the sun, kind of.
That's nice.
Yeah, that's better. You like the fuzzy, so you don't have to see me.
Yeah, sort of.
So today we have on Paul Ramsey, a friend from way back. You know, I was thinking about it this morning as I was grooming myself for the upcoming day. We knew each other. How long ago was it that we taught that PostGIS workshop for, what was it, GeoWeb?
It was GeoWeb, so that dates it.
Yeah.
Substantially. 2010.
Yeah, somewhere around there, right? Because that's when I had...
Or 209, I think 209.
And then we did the grouse grind or whatever that was, that trip. And I was going through chemo. So that's like forever ago. But we knew each other before that. Otherwise, we would have just been like, hey, let's just do a workshop together.
Of course, yeah. I'm not sure how the first introduction happened, but yeah.
Sure. Maybe it was at an Esri show. I doubt it, though. You used to go to them in the early days, didn't you?
I went to a few. Yeah,
me too.
A good party.
It is a good party. A lot of good Kool-Aid. So anyway, so we've known each other for a long time. We now work together at Crunchy Data, and we worked together just recently on this the spatial product, and pg-tileserv is one of them. And so I was like, oh, let's just talk about pg-tileserv. I think people are excited about it. So today is pg-tileserv, and Paul graciously agreed to join me so it wasn't just me blabbing at you as usual. Yeah. And so we'll do our usual banter that Paul and I do if you've ever seen us talk together. I do want to ask you about the rowing before we get to all the geo stuff. I'm excited about the rowing stuff, and we haven't talked about that yet. So do you want to talk about it for a second so people know what we're about to talk about?
The rowing?
Well, did you buy the boat or are you leasing?
No. I joined what's essentially a rowboat co-op.
Okay.
There is a company in town that makes what they call Whitehall Spirit rowers. They're basically on the outside they look like classic Whitehall rowboats, sort of clinker built wooden, but they're made out of composite poly.
Okay.
So they're tough as nails. And on the inside, instead of having like a fixed bench, they have the mechanics of what you'd see in a full-on rowing shell.
Like a skull thing.
Yeah, a sliding seat and carbon fiber oars and external oar locks so that your angles are all just right and you can really put some effort behind it.
Put your back into it.
Exactly. Legs into it. Exactly.
Oh, right.
And so I've been rowing in mornings now instead of like running and whatnot. It's been
I'm sure your knees appreciate that.
My knees appreciate it. My back is less sure because I'm still working on the technique. But
yes, but it is good for your back. Like
eventually, yes.
Eventually, yes.
Yeah.
And so you're part of the co-op. Do they store the boat for you and you just drive on down there or bike on? In your case, it's probably bike.
These are high quality boats. They're expensive.
Right.
There's 4 of them. 15-minute bike ride in one direction, another 4 of them 15-minute bike ride in the other direction. So 2 completely different rowing places: Victoria's Inner Harbor and Oak Bay.
Okay.
And you just grab them, toss them in the water, and go. You're back. Pull them back up on the dock. Walk away. It's the beauty of any sort of fractional ownership situation, right?
With something that you actually use as opposed to a timeshare, right?
Yeah.
Where you pay a lot of money and never use it. Although I'm sure there are some people. It's kind of like gyms, though, too, right? Like gyms make their money by selling tons of membership, and only a fraction of the people actually ever go.
Yeah.
But
so we'll see. I haven't had to fight for access to a boat yet. So
do you have to reserve it, or do you just show up?
Yeah. You reserve it ahead of time. So I'm going to have a boat for an hour. Yeah.
That's nice. And I guess the broader hull makes it nicer for your kids too, right? Like there's less.
Nicer for the kids. You're not going to fall over. You can go out in the waves. I mean, it's all. Oak Bay's relatively open water, so you can be in the swells and the chop, and you're not going to flip over. Whereas if you're a rowing shell, is only the width of your hips, right? So it doesn't have a lot of stability to it.
Right, and there's no what's that called? It's not a pontoon. I forget what it's called. Outrigger.
Well, no outrigger or anything, but it's a classic boat design. It's got it's beautiful.
Yeah. So do you ever feel like you're a newfie though? Like, not let's not make McKenna get upset that we calling
Yeah.
you a newfie, because McKenna will not appreciate anyone falsely taking the newfie. But do you kind of feel like a newfie, like you're going out for halibut or something like that onto the Outer
Not,
Banks?
no, not even close. I feel like the bougie yuppie that I am out in my slide skull composite rowing hull.
Okay,
Yeah.
so do you wear a beret then when you
I do not
actually?
wear a beret. No, I wear my New York Yankees cap. Yeah, it's very bougie.
Okay, good. I'm glad you're keeping up the Victoria bougie component
Yes.
there. Yes. All right, so that's enough chitter chat though. But I was very curious about the whole boat thing. It's nice to see seals before breakfast. I could do something similar here, but they don't have a timeshare. Like, it's like 4 or 5 miles for me. No, it's actually 3.5 miles, I think, to the Santa Cruz Harbor. I would love to have a sea kayak that I could do that with, right, and go out and see seals, sea otters, that kind of stuff. Have you seen? Wait, one last question, because I love them.
Go ahead.
Killer whales. Have you seen any yet? Do they come into those bays? Because I would love to see this from a boat.
They do go through Oak Bay, in particular. You're more likely to see them in Harrow Strait.
Okay.
I've not seen them yet. My guess is if I keep at it for several years, I'll get lucky enough to see the orcas. They're not that frequent. It's not like the sea is lousy with them, but
Okay. Or like the
will
San
happen
Juans
eventually. Yeah,
because in the San Juans, they seem pretty common in the San Juans.
that's for the residents. They're all hanging out just to the west of San Juan Island, but that's a little far away.
Yeah, you're not going to row over there.
Rowing wise, that's a little far away.
Well, you might run into the Coast Guard too if you drive that too as well. All right. Back to topics though, because that's not, people didn't come here to talk about boats, but I don't care because it's my stream.
Yeah, sure.
Today we're going to talk about pg-tileserv. So the idea with pg-tileserv is tileservs are all the rage. Tiles, map view tiles, MVTs are all the rage. A bunch of different servers can do it. But the thing is, most of the servers that do it are pretty heavyweight in that they do map view tiles, but they didn't do a whole bunch of other stuff, which you may not necessarily want. You just want tiles on the back of your map. I think this comes out of an idea, though, for you, Paul, that is bigger than just map view tiles. I've heard you talk about PostGIS, FTW, and it's not for the win. It's
for the web.
Yeah,
it's also for the win. But I mean, come on, it goes both ways. Just like PostGIS goes both ways.
Yeah, exactly.
So for the win, for the web, and this comes out. I mean, it comes out of, see me talk about PostGIS, particularly in front of a GIS audience. You know, my pitch will be: there's a GIS in the box. There is a whole GIS sitting inside this database box. Everything you can do with your desktop GIS, you can do in SQL with the database. And the same thing is true from the point of view of publishing data out to the web.
Okay.
You can generate all the web formats you want inside the database, which means you don't really need hardly anything between your web browser and the database. You need a tiny little shim layer that speaks HTTP at one side and generates SQL on the other side and then returns the results. And I first decided that, this would be a fun way to serve tiles, and wrote a blog post about it for Crunchy and said, it's so easy to do this. You can do it in like 50 lines of Python. And here's the 50 lines.
Right.
And, that was okay. It wasn't exactly production ready code. It was like, this is the proof of concept. You need nothing but to read the URL, figure out what that means in terms of the box of tile you want, then go ask for the tile, and then send the answer back to the browser. That's how it works.
Well, which is pretty similar to what I used to do, except I didn't even know about the JSON back then about serving up features, right? Like, there's just a very lightweight server says, give me a bounding box or give me a click and I'll make a bounding. Give me the viewport of the map, send it back. I'll clip the features. I'll buffer a clip and just send the features back to you, right? Like, I don't need to write some sort of complicated logic.
And without spoiling the punchline for next week, if you want to send in HTTP and get back to your JSON, pg-tileserv, same story, just with a different output format.
Right. So next week, Paul just did spoil it a little bit.
Yeah.
I was going to announce that I'm hopefully, if Martin's around. Martin Davis is the one who wrote pg-tileserv, and next week, probably Thursday, because Friday is when we observe Independence Day here, so a lot of Americans will not be. They probably still be around their computers, just not in a work-related way. I'll probably try to get next Thursday. I'll try to get Martin to come on and talk about pg-tileserv. Okay, so now back to tileserver. Go.
Yeah.
So, right. So then the other thing I think that really makes tileserv really exciting is we as a team, and you in particular, also focused a lot on as you said, it's just a shim. So there's no reason to make it really complicated. So it's super simple and easy to start up. Is that right?
That is right.
Okay.
That is right. Well, I mean, the core idea with PostGIS for the web is that so much of the information that if you're writing your middleware, as I did in Python, you end up writing a whole bunch of boilerplate, which says, when I get things in this pattern on the URL, all I'm going to do is I'm going to turn it into a SQL query, which maps them to these tables or this function over here in the database. But the database has already a whole bunch of metadata in it about things like, this is the name of the table, and this is the name of all the columns, and the types of all the columns, like all the metadata about what you're accessing.
Right.
Already exists in the database. There's no need to like recapitulate a binding in the middleware. You can just read the information out of the database and use that to present your HTTP external face. So yeah, you can, configuring it is as simple as saying, connect to this database.
And then you're done.
That's it.
Bingo bongo.
Yeah.
Bob's your uncle. So the other thing that's really great about it, though, is what language did you write it in?
Oh yeah, I couldn't help myself.
I know.
Couldn't
so
help
this
myself.
was just a little internal stuff, just so that you know, internally, when we were talking about this project, I was like, Python, 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 because we'll have more community people. And Martin and Paul were like, hell no, we're doing it in
Golang.
Yeah.
Go.
Yeah. Which I was like, oh, come on, guys, really? There's not that many people, and blah blah blah. How are we gonna get a community? Blah 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 blah. And they were completely right, and I was completely wrong.
It was a fabulous language. We've been very, very happy with it. The deploy is unbelievably trivial. And it turns out there is a pretty nice community of Golang contributors. I'm already getting quite a few pull requests against the repository, which is pretty nice for a project which is only a few months old.
Yeah, it's awesome. And we'll show that repository, and in the show notes, I'll put the link to the repository and all that stuff. But yeah. And so you'll see later, one of the nice parts about this is I'm just going to download a binary, call it, and we've got maps, right? There's no like, okay, well, first install Java, then install this, or first install the Python runtime. Make sure you've got these pip requirements, all that stuff. There's none of that. So you'll see in a little bit. Let's see, is there anything else? Oh, right. So what else is happening in the technology world at the same time is this idea of microservices. So what else did we do, right? Because we're the cool kids, because we don't have to be the typical geo of 4 to 5 years behind. I mean, we're still couple of years behind, but still we don't have to be quite as far behind. We decide this is a good place for this to be. So how else did we design this spatial architecture? Do you want to talk about that for a little bit?
Yeah. We thought we could build one big process and stick all of our endpoints into it. But in terms of being able to give people, like, we want to get more contributors in on all these projects, and we don't want them to have to figure out a big abstraction into which we've stuffed all of our services in order to start working on the services. So let's keep them as small as possible. So we went for a microservices architecture, but that just means that the tile server is distinct from the feature server. It's going to be distinct from a base map server, distinct from routing servers. I mean, we want to have all the services that you expect to see in a web spatial architecture, but all deployed independently and kept as small as possible. We think they can be tiny independent processes, and the problem of coordination and configuration can be delegated to the database. That can be the place where they all come together and have a shared state.
Right. And so one of the things this also does is really nice, since now we're in the container world, and this is the part I was kind of working on, is, and this is what I had said, I don't know, I think it was Phosphor GEU or something many, many years ago, where I said GeoServer should be rewritten as a set of microservices, right? Because it's such a, like, spinning up GeoServer takes forever and it uses a ton of resources, and I don't necessarily want the web processing service just to put up some points, and I don't need the entire security architecture you've got built in just to spin up some anonymous points, right? So I don't want to sit there and wait 5 minutes for my container to spin up and consume 4 gigs of memory. So one of the nice things is with containers in this, once Adam Tim finishes writing the catacoda for pg-tileserv, then we'll publish our containers in our official catalog, and then I will write the blog post and catacoda, well, probably catacoda, maybe catacoda, of how to publish it all in Kubernetes. And so you can set up a microservices that independently scale depending on load, and all you're spinning up is the pieces you need, right? So you can use Kubernetes as the part that decides, here's how I'm going to load balance, here's how I'm going to spin up and spin down, I'm going to handle security at the Kubernetes layer, I can do all that stuff, and I'm going to let the tile server just be a really freaking good tile server, right?
Yeah.
So with that, I think that's enough. You think that's enough background on it?
Start.
Okay, it's time to start. Let's do some demos. So I'm going to walk us through from start to finish, spinning up a database, putting some data in it, serving up some tiles. All live right now.
Boom. Go.
And then Paul will show off some cool demos of, like, some more stuff that you can do based on having everything in PostGIS. While I'm getting started, Paul, do you want to talk about some of, a little bit about your philosophy around a little bit more, like, in detail about stuff living in PostGIS? Because that's one of the other things, and we haven't said it yet. We made a very conscious decision in the beginning of this project that we're very opinionated about what your data source is and what we're doing. Like, so, what's the project? The other Go tile.
Oh, there's another, so another Golang tile server is Tegala.
Right. And so Tegala, wait, let me just say one thing about Tegala. Tegala works with shapefiles, works with GeoPackage, works with PostGIS, works with a bunch of stuff. And so because of that, or they're doing some, maybe they do, we saw a couple little pull requests or something around that, but they basically can't use the as MVT function in PostGIS because they have to do their tiling at the tile server layer, not in the database. And now go.
Now that you've taken it all, yes, they very reasonably said, we're making a tile server. It should support multiple formats. And so they support multiple formats, but that means they have an abstraction layer between their data sources and the tile generator. It means they have to haul all the raw data over the pipe from the database or whatever the data source is before they generate the tiles. We did not say we're going to write a tile server. We said to ourselves, we want to expose PostGIS's tile generation facility to the web. And that very drastically changed the amount of software we had to write and the size of the project that spit out the back end. It also means you can only run it against PostGIS, which is the point. But that's fine. There is this theory that people change their databases all the time. There is this reality that people pick a database and that's the database their system runs on for a generation. So we don't think that if people have chosen PostGIS, they're going to feel too bad about using a PostGIS only tile server.
Right. So the only thing, if you haven't chosen PostGIS, the only thing you might have to get comfortable, or if you're still storing some stuff in PostGIS and some stuff in shapefiles, get better at your importer. That's the take home, right?
Yeah.
Now I have to look this way at you. You have to look because you're now above me. All right. So first thing we're going to do is we're going to spin up a Docker container. I went through this because nobody likes seeing errors or typos beforehand. So I'm spinning up a Docker container that has Postgres in it and PostGIS. We're going to call the container as SC data because we're going to load up some data that we did for PostGIS Day back in St. Louis in 2019, a couple centuries ago. And we're going to call the database is going to be called SC data, and so is the container name. And I'm just going to run it there. Now I've got PostGIS running. So now I'm going to go get the data. Okay. Open a new tab. You should use Firefox rather than Chrome. That's just my little editorial. So we're going to grab the data here, right? And it's got a nice little how to import it. So we're going to do download the data. We're going to save that file. Beep. Okay, that's all done. Now I go, because the only way to get pSQL in Windows is to install the entire Postgres suite. I didn't do that. So you've seen this before in other podcasts where, or videocasts or streams or whatever you want to call them. I use Windows Subsystem for Linux. We're going to do this little command and I'll walk you through it as I do it. Right. So basically unzip that file. Oh, no, that won't work yet. Hold on. We got to get rid of that because we're not in the right directory yet. So CD. Can you see that?
Very small in my world.
It's very small. Okay. Is that better? How about people on the call? Can you see that? Timothy, come on, answer me. I know you're there and you're not shy about talking. All right. Anyway, it doesn't matter. Timothy hasn't answered me yet. He went to go get some coffee. C, user. Oh no, it's capital U. Users. Steve. Downloads. There we go. All right, now I can do that command because I just downloaded the data. So I'm going to unzip the file and then just stream the contents to pSQL on the one I just spun up. The user is going to be Postgres, and I'm going to put it in the SC data database that we said we were going to. Good. Created all the data. Now we have our data. Oh, it's almost done. Hold on. That's fine. Test tables doesn't count. We put our data in. It's all in there. That was quick. Now, next stage, we're going to go get pg-tileserv. So let's copy this URL. We don't need this page we do actually need that page. Let's go here. Let's go get pg-tileserv. So here's the repo for it, crunchy data /pg_tileserv with no E on the end. because we're bougie like that. Because this is a
Yeah.
microservices bougie world.
Exactly.
Exactly.
This is bespoke. This
we should
is
have called it
local.
pg-tileserv.io. Right.
True.
Super, super bougie. Although maybe there's a new IO. Maybe IO is so 2018 or something. Anyway, it's really easy. We just download the Windows. This time I am going to actually just open it because it's self-contained. Now, this is the nice part about using Go. We can actually compile for the binary for all these. Well, not the Docker platform. We make a container, but we have all the binaries for Linux, Windows, and OS X, and it just runs natively. And you can see here I've got an assets directory. You need that to be there. That's got the background stuff that it uses to draw its pages. So I'm just going to take all of this and put this in the downloads directory as well. I'm going to browse. Let's put this all in the downloads directory just so that we can keep everything. Select folder, extract. Okay. And so there you can see I've got pg-tileserv and I've got the configs and the assets. This is the real hard requirement, is that assets has to be, unless you specify in the toml file something different, it has to be in the same directory as the binary. All right. But that's all it was. It was just an unzip. So why is this also great for you as a user? Does anybody know why? Because I'm doing this in user space. Did I have to contact any administrator or something to put this in there? No. It's just one single binary that I can run from my own space, right? So it's not a problem. So we don't need that anymore. All right. Now I open a command prompt. Here we are. Let's make it a little bit bigger. There we go. Ready? Now, let's just start it up. Let's see what happens. So we cd to downloads, pg-tileserv. It says, I'm going to try to start. You don't have a database at local. It assumes that there's a database that's at localhost with the current username. And it says, I got nothing. So, okay, great. You're right. We need PostGIS. We already said that. So we're going to have to tell it what its database URL is. Right? And so we're going to do this set, the database URL, PostgreSQL, the username. Now I'm going to use the username of a different user, not Postgres, just as the Groot user. And the Groot's username is the password for the Groot user is password, and it's localhost, and we said it was scdata. So we set that. Now that's an environment variable. You could also have set, there's a whole config file we can set, but if you want the cheapest and fastest way to get started, this is probably the easiest. And then we do that same command again. pg-tileserv, it says, look, I've connected as Groot to scdata at localhost. And it's running at either 7800 or 7801. Well, we don't know Woot yet, right? We're like, okay, that's great.
We'll find out in a
We've got something running. Woohoo! That's not much to show people, though. Doesn't make you feel like a wizard yet. Although, this is kind of wizardy. I mean, for those of you who've tried to run map server or tried to run geoserver or tried to run and successfully run them, but when you start it up, there's a lot more you have to do. This is kind of wizard, right? Like, I download a binary, I set one connection URL, and the binary actually says it worked. Like, that's a huge step in and of itself, right? So then I can go to localhost 7800, right? Did you have some reason why you picked 7800 as the default? Do you remember?
No, I have no idea why I chose that.
Okay.
I guess 8800 is a classic high port, and it's like, well, but everyone's on 8800, so I'll just take 1000 off.
That's right. Okay,
yeah,
that's fine. I was hoping it was like some sort of Canadian reference, like it was about some song that Rush.
Yeah,
like
it's a Gord Downie thing. Yeah,
or bare naked ladies, right? Yeah. Okay.
Yeah.
So Justin Trudeau. Anyway, here we go. We're gonna hit it, and it's running. Now you're like, that's not so exciting, but it is exciting. Because look what it's already seen. It looked into not just the public schema, it looked into all the schemas it had access to and found all the layers that were available. If I want to see all, I can actually call the index.json and get the detail URL for each of those. I can click on that and it actually tells me about each of those layers. Like that's the parcel one, right? And it goes through and tells you all the detailed information that Paul was talking about before. With the database already has all the metadata. I can interrogate the database just to get the metadata. So it's just doing it automagically. Now, here comes the good part though. Hold on. But it also gives you a preview for each one of these. So I'm not going to start with parcels because parcels is a interesting one. It's got a lot of polygon features. Let's start with something a little bit simpler, and we'll get to parcels. I promise I'll show parcels. There's nothing hidden. But let's start with fire service areas, right? And boom. And it was so fast that you basically didn't see the tiles come in. But I promise you, these are tiles that just rendered all those polygons, right? And you'll notice these boundaries as we get closer.
Yeah, if you zoom in fast enough, you can see the slightly more detailed tiles come in, but you have to zoom in pretty quick.
Yeah, because it rendered well there. Now you can see now you can see that it was tiles actually, but no, I can't do that one fast enough. We'll do it faster on one that has a lot more features. This is just a few features, but you can also use this for things like lines. It's not just polygons. Like, so here's all the streets. Oh, these are the streams. Sorry. So now this one I should be able to zoom in. That's a lot of features. Did you see how fast it rendered all those features? Now let's go fast. I'm not fast. My zoom isn't fast enough. Did we see it there? That's a weird stream.
I'm not seeing them.
I'm not seeing it either.
That's a really ugly stream, yeah. So, I mean, the reason you would see anything at all is because vector tiles have a fixed resolution, by default 4096 by 4096. So if you're zoomed out far enough, like that view of all of Santa Cruz, then the points in the vector tiles are not exactly at the location in space where the actual coordinates are. But as you zoom in closer, that 4096, 4096 effective resolution gets more and more fine relative to the actual raw data. So if you go in fast enough, you can see it sort of looking chunky as you're looking at the original coarse stuff, and then it flips
to the new one.
The higher res vectors come in.
Okay. Yeah. So now the other thing you're going to say is, well, how much resources is it doing that? So let's do Control Alt Delete. Let's do Control Alt Delete. Why isn't Control Alt Delete working? I wonder if it's because I'm in OBS Studio or something. Let's see if I do it over here. Control Alt. Oh no, because I'm pressing the Shift key. Okay. So here we are. Let's find pg-tileserv. It's not running there. Oh, it's actually probably going to be in the command prompt, right? Do we have the command prompt? There it is. So there's the command prompt. And the memory is right now 12.5 megabytes for running the command prompt. All right. So that's how much memory. And you want me to leave it up while well, it won't stay on top.
It's going to be hard to see.
Yeah. Actually, I can probably do this.
Zoom in and out.
Wait, hold on. Yeah. Or you know what we'll do? We'll do the one I promised I would do.
Yeah.
Okay, so the line is... Oh, rats, that's not what I wanted to have happen. No, don't do that. What happened there? No, don't do
Windows
that.
happened.
Yeah, Windows happened. It's the multi-monitor thing. Okay, we're going to cover us up for a second. It's the blue line. There's the CPU and memory for the blue line. I'm going to do parcels, right? Because this is when you get to see where we start to run into where you actually have to worry about parcels. Rendering. So here's parcels, right? Now, Paul, when I first did this, I said, what happened? Where's all the rest of the parcels? I know there's more data there. Paul, what do you want to say about what happened to the parcel? What happened here?
In order to avoid you crushing your database on a default install, we do limit the number of things by default that will go into a tile. I believe it's limited to about 10,000, maybe 20 per tile. So there's maybe there might be 2 tiles showing on that map, maybe 4. Anyways, they fill them in until they get to 10,000, then it stops. You can configure it to be larger if you're okay with it taking longer for tiles to generate. But then, the tiles will be quite large.
Yes. Because
you're literally taking every parcel in Santa Cruz County and stuffing them into a tile.
Right.
They won't be as large as the original data because it will be quantized down to the tile resolution and so on. But still, every parcel will get 4 little points in that tile, at least.
Right.
So it takes up space. And the thing to do when you get something that's detailed, so detailed really you can't see it at that zoom out level, is really to not send them in as vector tiles, but to have some sort of overview instead, like say the zoning areas or just the city or the county boundaries or the city boundaries, and then flip on the parcels when you get close enough for them actually to be usable as parcels. Because you're neither be using a hover nor a click nor anything against them. They're all too tiny. Most of them are smaller than a pixel.
Right. And so the other point here is we're only looking at the preview, right? This is probably for production use for sure. This is not how you're not going to send people the preview URLs and say, here you go, right? What you're actually going to do, I'll come back to this in a second, but what you're actually going to do is you'll go to the JSON, right? And then you'll grab, there's a lot of variables for the parcels. You'll grab this URL at the bottom and plug this into something like Open Layers or
Open Layers or Leaflet or Mapbox GLJS.
Exactly.
Anything that takes up PBF vector tiles.
Exactly. And then change the zoom level to be one that's more like, you'll say this layer doesn't turn on until we get to something like that, right? Where you see where you can see the details, right? That's where you would do it. So then you can see as you zoom around, it's pulling in new tiles, but you can see how fast it is. Look at the CPU on the blue line while I'm doing this as we're pulling in new tiles, right? It's 0.1, 0.2 CPU, and it's using 19 megs of memory, right? I mean, this is exact. And so if all you need is a tile server, or if all you need is a tile server and a feature server after next week, this is exactly how you do not exhaust the resources on your server, right? You let PostGIS do all the work, and then you have this nice little shim layer that's just basically shuttling data back and forth, right? There we go. See, so look how many there are there. And I think if I click on this, I can get all the data from it in the preview, right? Yep. So showing you that the vector tiles has all the information below them, right? So this is
that is not an image. That is real vectors.
Yeah. So I think one of the other things that, and having worked in consulting before for conservation biology, like the field biologists would often ask, oh, how do I want to look at blah, 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 blah. You can run this on your local GIS desktop if you wanted to, right? Because you notice I just started it up by saying pg-tileserv. If you know that they're going to want to just look at these maps and you've got PostGIS running on your local machine as well, or even if PostGIS is on a separate machine, but tileserv is running on yours and you've got the connection information, you can send them the URL for this page. Or what you can actually do, and I didn't have time as I thought of it while grooming this morning. My grooming time is it's particularly when the hot water is running on me, grooming time, is usually a very good thinking time for me. But you could actually make a simple HTML page that sits on their desktop. That doesn't have to have anything else behind it. And all it is call outs to your tile server, and then whatever base layer you want to use as the base layer. So like if you want to use OpenStreetMap, you could use OpenStreetMap as the base layer with your resource sites, your survey locations, whatever it is that you want to show up. It can just be an HTML page that they can pull up at any point in time. And as long as your tile server is running, that page will work for them. So you just have to make a local HTML page that they can just double click and open up, and it'll just work, right? There's no big servers for you to install on your machine and bog it down, right? You could just always be serving it up. So
yeah.
I thought.
So is it my turn now, Steve?
Yeah, it's your turn. Fine, go.
Thank you. All right. Let's see if this works. Oh, you got to let me do it.
Oh, I got to let you. Oh, right. Oh, yeah. Your turn. This is so great. Sorry. Host disabled. I'm the host.
Mm-hmm.
How do I go in and change that?
You changed it yesterday.
I know, but that's because I started it instantaneously. How do I, what? All right, hold on. Let me go into, I'm going to start a new meeting. And I'm going to invite you to it because life is that way. You're already in the meeting. Do you want to leave and join this meeting? We're going to leave. We're going to come right back. Is that okay?
All right.
We did this yesterday and it worked, but it's because I scheduled it now. Sorry, everybody. Hold on. We'll be back in a second. I'm going to turn on Slack too. Okay. Just so that we can talk to each other. Hi, everybody. I'm back. But now I have to participants. How do I add another participant? Are you guys all Zoom experts? No, I want to add another one. Oh, invite. There we go. Copy invitation. Okay. Send it to Paul. Okay. He should be here in a minute. I should have done this earlier on. Sorry, we didn't know that sharing wouldn't work. So share. Multiple participants can share simultaneously. So when Paul comes in, he's here. Admit him. He'll be coming in. All right, here comes Paul. Don't leave. Don't leave. This is the best part. Paul's back. Hi, Paul. Can you hear me? No?
Gotcha.
Okay.
All right.
So now you should be able to share. See, can you share?
I can.
Okay. Good. Now let me just make it full screen. Hold on. Oh, it made it full screen anyway. Good.
Mm-hmm.
Go.
All right. Let's talk about this thing. So what's a tile server? This is in the very most generic sense. A tile server is a thing which takes in an HTTP request, that mentions the server it's going to, some magic numbers the zoom level, the tile X, and the tile Y. Format, if it's a vector tile server, the format is portable binary format, and then maybe some extra parameterization. And the tile server then does something magic, and then returns for you a vector tile that corresponds to the parameters you sent. And you look at that and you say, okay, so that's not very hard, and most of the things in it can be just mapped across the database. And Steve already showed you the idea that the tables map across. So the server, pg-tileserv, finds tables and maps them across. But what if you want to do something more complex? What if you want to do something which changes its results based on parameters? And the answer is, yeah, you can totally do that. In addition to publishing tables, every table that it has, that the user you connect to has access to, every function that has this signature, a function that takes in a zoom, an X and a Y, so 3 integers, then any number of parameters, and returns a binary result. If the tile server sees functions of that signature that its user has execute privileges on, it'll publish those as functional tile services. And let me show you what that actually looks like. So I'm going to turn on my tile server here. It's connecting to my natural earth database, up and running. So if I go back to Firefox and reload, okay, so here's my tile server. I got a whole bunch of table layers in there, a bunch of natural earth layers, but I also got some function layers. And just like the table layers, there's a JSON link, so you can go in and get metadata about the function. So this is my country's name function. It's got a tile URL that you plug into your web client, just like before. But it's also got information about the arguments. So this function, country's name, takes one argument, the name prefix, of type text, and will fill in a default B. And because it's all this information about the arguments and the parameter types and the parameter defaults is published in the JSON, it's possible to make a UI that self-configures, so you can preview these things. So we actually have a preview UI as well. So all country's name does is take the existing countries table and give you a view of it, which is subset by this name prefix parameter. So the default is B, and here's all the B countries: Brazil and Bolivia, Burundi, Belgium. And change it out to the much more attractive C countries, like Canada and China and Chile, all being generated on the fly. These are all vector tiles. So you zoom in, their little edges will sharpen up because they're vectors. The difference is the dynamism is being added to the SQL query. And all that's happening in the back end is we have this little function called country's name. Like I said, it's got the signature that the tile server could recognize. Oh, 3 integers, a Z, an X, and a Y. That must be a tile producing function. And then any number of parameters you want to add to your function. This one actually goes and selects data from an existing table, the countries table. But unlike the sort of standard query, this is almost the exact query that tile server runs by default against tables. It just has one extra line in it, the one that subsets the result by using the parameter as a filter. But because of the function, there's no reason that these functional tile services have to reference data that exists in the database at all. So for example, it is possible to generate hexagonal coverage of the world dynamically. So for each tile request that comes in, the function says, okay, you want a tile this big, and I will fill it with how many hexagons? Well, I'll fill it with 4 hexagons on the side. Or actually, no, 2 to the 4th hexagons, I guess is how I programmed this one. So quite a few hexagons, actually. There's 8 hexagons on each edge, roughly, because hexagons don't perfectly fit tiles. So if I increase it to 5, that'll double the number of hexagons we see. They're all being generated programmatically. as you zoom in, you get smaller hexagons because each tile is filled with exactly the same number of hexagons. So the hexagons are getting smaller in spatial terms as the tiles get smaller. And you can make them smaller yet. Ugh. So that's pretty cool. And it's even cooler when you combine this with raw data, because the thing you use for hexagons is not looking at hexagonal stuff, interesting though hexagons are. It's for summarizing other data without imposing some sort of arbitrary, or without imposing a non-uniform arbitrary basis like counties or states or something to your summary basis. So here's my last demonstration. I've got in this database a table of populated places. It's just a bunch of points. Here it is. It's got a lot of attributes. So it's really hard to see them. All the attributes in the way. You can see there's lots of points there. These are basically a point for every city with a population attached to it. So that's one way of looking at this data. The other way of looking at this data is to say, what if I summarize them by hexagon? Can I do that on the fly? Indeed, I can. So this function for each tile generates the hexagons and then joins that hexagon tiling spatially to populated points and sums up the amount of population that's in each tile. For tiles that have no population, you get no hexagon. So this is kind of coarse right now, but as before, as you zoom in, the hexagons get finer. Because they're generated dynamically, you can actually update and change.
Paul, why don't you click on one of the hexagons, though, too, so they can actually see the population?
Yep. So over here in New York, there's a very populated hexagon summarizing the natural Earth pop max and pop min, which I never figured out what they mean, but anyways, this is summing them up. But over here, like a smaller one in the flyover states, not a lot of population there. Seattle, quite populous. So yeah, these are actually summarized. It would be prettier if I could do up coloring on it, but that's hard to do in generality. And this preview UI has to handle absolutely any function that people can define. So we don't necessarily know what colors to apply to things. So we just show the attributes and use blue.
Right, it's just the preview. I mean, the whole point, again, this was that simplicity thing. The preview view wasn't supposed to be the production view. It was just like, oh, look, I've got things, and they return, and they have attributes and do things. But it's not like, that was never the intention for the preview view. It's just, yes,
Adam
it
likes
works.
to refer to it as the engineering UI, which is a nice way to think of it. It's the UI you use when you're setting things up and testing them and making sure that stuff is actually connected and the parameters actually work the way you expect them to, and so on. And once you got that all done, you hook it up to your actual UI, which presumably is attractive.
Right, and you could actually use like Firefox's the developer console to look at the URLs you're pulling for that and copy and paste that into OpenLayers or whatever else you needed to put them into. Right, that's part of the point. It's not that that's where you're doing your styling. So
that's all I got, man.
What do you mean that's all? That was a huge amount. So
cool.
While we were talking, while you were demoing. Earl, I looked at the chat, and Timony, of course, has a question about, is there a crunchy preferred, which is the answer is no, but Paul might actually have opinions about...
I've opinionated, actually not a particular one, but just a structural architectural opinion about caching, particularly with respect to vector tiles. There's nothing special about caching vector tiles. So I think any reverse caching proxy, you stick it in front of your tile server. I think that's a best practice in production. Obviously, when we're playing with our local desktops and whatnot, doesn't matter at all. But if you put one of these in production, you definitely want to put a reverse caching proxy in front of it. It doesn't have to have a very long-term cache, right? It can cache things for a minute or 5 minutes. You just want to prevent any large spike in load from dumping all of its effort against the database. And generally, the spike and load is like repeatedly asking for the same thing over and over again, because you don't want to repeatedly generate the same tile out of the database over and over again if it's not changing. So you'd set your cache to have a timeout that approximately matches the volatility of your data.
Right. And then one other question. So you're saying you don't need a geo-specific caching layer for this one, right? You don't need like geo web cache or anything. It could be Squid if you really if you're into Squid.
I mean, the thing about the old, I can't help but go in the weeds, right? Why is there such a thing as a geo-specific caching web cache? And it comes down to the fact that for image tiles, which are sent back with their exact bounds, rendering is a big problem. So you want to render things in batches so that they're rendered in sort of a big swath and then cut up after rendering. So you have this idea of a meta tile, which is then cut up into the actual tiles. So there has to be a sort of extra smarts going on in the image tile caching system. Vector tiles always include a render buffer around them. So they actually ship more data than the tile boundary. So the renderer on the client can do a little overlap rendering. And the tiles actually lap each other.
Right.
And the renderer just over renders on both sides and then cuts off the extra and sticks them together for your display. But the net result is you can independently send these tiles back.
Because it doesn't have to know
tiling required.
Right.
Yeah. So a simple cache then works just fine.
Okay. So all you Squid fans, rejoice.
Squid it up. Yeah. Squid will do it. Nginx will do it. If you're old school Apache, there is a reverse caching proxy in Apache as well. So,
or if you want to be hipster, you could use like memcache or something like that if you wanted to, right? Couldn't you just throw the images and the tiles into memcache?
I mean, yeah, but then you're writing your own.
I know. Well, Redis isn't Redis the cool caching server? I don't know. I'm trying to be hipster.
Policy, right? It's just like, there's. Yeah,
I know, but I
tried to avoid getting into. Again, this is the microservices thing. Yes,
I know.
Add a cache into it, and like Tegela has a little inbuilt cache. Like, cache. There's like 4 things that are hard in computer science. One of them is caching. Anyways, I don't want to do it, and there are other things that already do it.
I agree.
Architecturally, there's no reason.
So whatever your favorite caching agent is, use that, Brian.
Yeah.
We don't want to. We like you having your favorite and feeling validated in your choices. Okay, so there's another one. Oh, is there any special considerations in setting up when using a cloud version of PostGIS like in Aurora? Well, you should use the crunchy containers first off. I just want to say, but if you somehow choose to use Aurora, go ahead.
Not entirely. The main thing you'll find with the cloud versions is that they lag in their PostGIS versions. And one of the things which is true of PostGIS's tile production is that it has gotten faster and more reliable with each succeeding version. And 3 is definitely the best across a bunch of, both in terms of producing quality tiles and producing tiles fast. It is the best. And probably 3.1. Which will come out in the fall, and hopefully with new GIS underneath it will also be faster yet again. So the cloud systems tend to lag. So that's the only downside, but they do work. I think they have like PostGIS 2.5 in Aurora, so that's fine.
Okay. So that's it. So yeah, so what's the minimum version that you can use this with?
2.4.
Okay.
It's the minimum one that produces vector tiles.
Okay. So just to everybody know, you got time to upgrade to 2.4, at least if you're not. But you should go straight to 3 if you can, because 3. And then there was funny. We were doing a demo for a potential customer the other day, and Paul's like, "Oh, it's so much slower here," and it's like, "Oh, right, because I'm using my dev version of PostGIS 3. Is it 3.1 or 3?
3.1. Yeah, I was doing spatial joins, and they took like 60 times longer. It's like, what have I done wrong with this query? Oh, it's not the query.
Right.
It's just my new version is that much faster.
Yes. Yeah. So that's also a big hype up for 3.1. There's another interesting question from Justin. Thanks, Justin. The doc says the API looks a lot like Martin. What is the motivation for writing a new server?
The main motivation for me was I want it in Golang. I like the idea of Rust, but I think Rust is still getting a audience, like compared to Python has a huge audience, Golang has a smaller audience, Rust has a smaller yet again audience. So yeah, the motivation was that. And then just the selfish one of wanting to do a project which was both big enough to require me to learn it and small enough to not have to spend 6 months on it. So.
And I also think one other thing about it that now is in retrospect obvious is that Rust doesn't maybe never have all the accessory libraries yet that Go had that made a lot of the stuff that you guys did. You're like, oh, it was so nice just to use this package and whoop, I got all this nice stuff, right? So
between Martin and I both came to Go fresh.
And this Martin, wait, hold on. The Martin he's talking about
Martin Davis, the human,
right?
And I both came to Go fresh. This is our first projects in it, and both are blown away by how productive it is. And then simultaneously how lightweight and fast the stuff it produces are, and then the incredible flexibility and convenience of being able to roll out binaries that have no extra dependencies.
Oh, so nice.
Yeah.
So nice. So I think with that, we're pretty much. Oh, wait. Is there a simple example to put pg-tileserv on a Mapbox or leaflet page? Well, funny you should ask. There, if you go to the Crunchy documentation, hold on, let me pull it up. pg-tileserv. Oops. It helps if I know how to spell it right. My typing is off this morning. Here we go. Oh no. What? No, it must contain tileserv. Oh, but I spelt tileserv wrong. There we go. Where is it? Never mind. Just let's do pg-tileserv. And I think the doc is where is it? Oh, you know where the link is? Paul, you should interrupt me, even though I know
you're at the top of the readme.
Yeah, it's at the top of the readme right here. So if you here's some examples. And there's an open layer example. There is a leaflet example. And then there is a Mapbox.js example. So does it, open the HTML in your browser. So the place for the documentation, if we go home, and this is also, you've heard me talk about Kat before. Kat was one of our documentation specialists who helped put together this fine-looking, well-organized documentation. So kudos to you as well, Kat. This was a really fun project in lots of ways for us, right? Working on Go, working to put a nice documentation process, working with small little services, leveraging I really had a lot of fun on this. But
yeah.
Anyway, so I think we're pretty much done. I'll put a links to the doc and the GitHub repo and the binaries are in the doc. What else should I put links to? Oh, is your fun examples up anywhere permanent?
Yeah, they're part of the readme.
Oh, never mind.
Yeah,
they're part of the
hex example, the overlay, the country one, they're all part of the readme.
Okay, so then I'll put those all up. And I'll probably put a link to Paul's Twitter account if you aren't one of the overlap between my Twitter and you. I'm a subset of yours for the most part, but I'll put it up anyway for those one or two people here who are not geo people who didn't know who Paul was beforehand. And I'll put up your Clever Elephant blog as well. That sounds good.
Nice.
Yeah. So with that, thanks, Paul. Thanks, audience. This was a lot of fun. And next week, we'll try to get Martin here as long as his schedule agrees. And thanks for sitting through us while we work out having an interview rather than just me talking. So, all right.
Thanks, everyone. Thanks, Steve-O.
Okay. Thanks, guys. Bye.
Bye.